Thank you for your nice introduction. Hello, my name is Mariusz Gil, and today I would like to talk a little bit about the machine learning. I would like to share some concept about the machine learning, what the machine learning is, and where we can use the machine learning techniques in our applications. But to be honest, don't expect a comprehensive introduction to the ML, because there are, I think, very nice places like Coursera or Udacity where there are some machine learning courses, and this is the best places. This is the best place where you can collect some knowledge about the algorithms and the basic stuff and the core concepts of the machine learning. So this talk will be about the machine learning usage, about some problems we discovered in some our past projects. To be honest, I'm not a Ruby guy. I wrote my last application in Ruby. It was years ago in a framework called MERP. Do you remember the MERP framework? Yeah. So this was my last big application written in Ruby. But I love Ruby for the syntax, and that's sometimes I use this language. So I'm not a Ruby guy, but I'm the PHP guy. I know. So, thank you for the applause. So, I work with the PHP community. I'm one of the PHP Earth group community members. We are trying to adopt and promote good techniques for writing and applications. Okay, so on a daily basis, I'm working in my own company called Source Ministry. This is a very small one-person company. Yeah, but there's one thing for me very important. Every day, I'm doing what I love. For example, I spent all the day today doing an event storming with a team in Wrocław on very interesting domains. So this is what I'm doing on every day. I'm trying to help people. I'm trying to help the companies to be better. So about the clients, I'm working with different clients, huge portals and the huge applications, or sometimes very small clients. And about the clients, about their problems, I would like to share, and I would like to start from one very interesting project. This is a project I started to thinking about the usage of the machine learning. So one of my clients, one of my friends, has a very successful and very popular website in Poland. It was a lifestyle portal focused on women. But one day, my friend realized that there's a problem. In the Google Analytics, the trends are not so good. The traffic went down, the users are trying to disappear, and if there is no traffic, if there is no users, there is no money in the pocket at the end of the day. So my colleagues started thinking, what's going on? And after small investigations, they realized that someone, probably a competitor, created a lot of bad backlinks pointed to his websites. And this website was punished by Google. The part of the links were removed from the search index from the Google. And if you are not in the Google, you are not in the business. So my friend contacted with Google and asked, okay, what we can do to help to solve this problem. And the response was very simple and short. You need to submit a disable file, and you need to point what kind of links you would like to remove from our indexes. And the problem was that this application was very popular, and the overall number of the backlinks was a couple of millions. So try to imagine how many times, how much time do you need to classify these links? So my colleague said, okay, we need to analyze our backlinks. We need to classify them. You've got one single file. This is a file with 1 million backlinks, and I would like to have 3 files. You need to split this single 1 million backlinks file into 3 files. So it was something like that. This was a 1 million backlinks file, CSV file, just URLs, nothing more. And you need to split this single file into 3 groups. The first one should contain only OK links, only the links from websites like Onet or similar websites. I mean, you would like to have a backlink from the news portal, right? The page rank of the onet.pl is something like 8 or 9, so this is very nice situation to have a backlink on this page. And the second group should contain only the links we would like to remove from the Google. For example, this shitty website. And during our investigation, we identified a lot of thousands of websites created by spammers just to create and publish some links. For example, we identified few pages where the overall number of links of the page was 60,000 links on single page. So what is the point of this website? Black SEO, nothing more. So, and the third group is something like I don't care. Maybe I would like to have this link, maybe not, I don't care. So this example is maybe very, very artificial for you, but in the context of the business, there was a case of the knockout. I think some of you remember this situation where knockout was punished by Google, as well as my client, because of bad SEO. Someone from internal SEO team in knockout created a lot of links, and the company was punished by Google, exactly the same way. So if you remember the situation, the knockout has an initial public offer in progress, and when this problem occurred, so the initial public offer was cancelled, and so the knockout is not of the stock market until today. So try to imagine, you've got the single CSV file, 1 million of links, and you need to classify them. What can you do? You need to transform these URLs into the numbers. If you've got just URL, it's a string. How you can identify what's going on this page? You need to take a look on this page. So if you are a human, you can open the browser, check what's going on the page, and classify. Repeat 1 million times. So it's a complicated situation. So we started, our client started thinking something like that. Please transform these URLs into set of the numbers, into the vector of the numbers. For example, what is the age of the domain? How many links we've got on every single page, in the header, in the footer, in the middle of the content? How many H1 headers we've got, etc., etc. And provide me a CSV file, an Excel file. We will try to identify a formula based on this data. So our first approach was something like IF-OLOGY ugly code for proof of concept. Okay, let's try this approach. So we created a PHP application using the RabbitMQ, not Kafka. But in other projects, we checked the Kafka because the RabbitMQ wasn't the best solution in this amount of data. So we created the application, and all the URLs were fetched, checked, and analyzed, and some metrics were created. So we created a lot of files, and the files were sent to the client. And what do you think? What was the response from the client? Sorry guys, I don't know how to find a formula for this data. So if you've got, let's say, 8 columns, maybe not 8, 3, 4, I think you will be able to find a formula, a correlation between the columns. If you've got, let's say, 70 columns, 80 columns, this job is a little bit more complicated. So because the correlation is not so linear between the columns. So our client said, okay guys, probably we need to cancel this project because we can't find the formula. We spent a couple of days, but this job is too hard. So we tried to think how we can help our client, because as I said, it was our friend. So we convinced him, okay, please, let's try another approach. So we are not the experts in the machine learning, but we would like to check something. Okay, please give us 2 weeks, and after 2 weeks, decide what is the rest of the project. So we tried the second approach called, after the time, naive machine learning. Naive keyword is very, very important in this situation. So our expectation a few years ago was something like that. We've got the data. data are collected. We've got the CSV files. We've got the vector of the numbers for every single URL you've got. And we know what we want to do. We would like to classify these informations. So, sorry. All we need to do is get this data, send to the machine learning task to get the results. Simply? Simply. And this approach was completely wrong, and we failed because of two things. The first, the copying pasting from Stack Overflow is not the best idea. And the second, trying stuff until it works also is not the best idea. So this is a moral from the situation. For no matter what you're doing, if you don't know what are you doing, so doing without the knowing is a recipe for the failure, always, and no question about it. If you are trying to use event sourcing and you don't know the event sourcing concept and you don't know what are the problems in event sourcing, you will fail. Maybe not the first day, but let's say in one month later or something like that. Okay, so we get some information from this approach. Realize what went wrong and what kind of fixes we need to apply on our approach. So after a few weeks, we tried a third approach called data-oriented machine learning workflow. And after some time, this application, this approach was introduced to the production system with 95% of accuracy, which was awesome, honestly. Okay, so there are a few things on this slide. The machine learning, what the machine learning is, and the workflow. What kind of workflow we need to create in our machine learning process. So the typical definition for the machine learning is something like that. A computer program is set to learn from the experience E, and experience is very, very important in this situation, with respect to some class of task T, with performance measure if this performance at this task as measured by P improve with experience. So this is a machine learning. Maybe this is not the best idea to read this slide. So we can create, I can introduce this information in some graphical context. So we've got the data. We've got some machine learning task. So we need to prepare our data a little bit for this machine learning job. Then we can create some learning algorithms. We can validate our models. And then we can use the models to get the results. With carrying a take of performance, of measuring of performance. If you will not measure your performance, you will fail. So this is a machine learning concept, and the machine learning will probably not 100% in accuracy, in the context of accuracy. It's very hard to create 100% accuracy machine learning. So sometimes your solution will be wrong. And this is about the learning, so you can fix your machine learning decision. So if the machine learning decision will be wrong, you can correct and create another data set for another iteration of your model, and etc., etc., etc. Create how many loops as you need. So the most important information of this slide is the machine learning task. What kind of task I can solve using the machine learning algorithms? So, for example, I can classify some object into some contexts, and our job in this first project about the machine learning was about the classification. We need to classify every single URL into one of three groups. So, for example, maybe in this situation we've got the developers in the room. Maybe some of you are juniors, maybe some of you are seniors developers. So I think it's possible to create a classification based, for example, on GitHub data to classify you as a junior or the senior developer. Okay, so sometimes we would like to predict some continuous values. For example, what will be your salary as a developer if you are no blah, 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 blah. So based on maybe some of your experience from presented on the linked in pages, maybe about the what kind of data we can use, for example, maybe some salary models in from the cities or countries, something like that. We can also use the regression algorithm, for example, for predicting the value of the stock on the Monday. Okay, so where we can use also the machine learning, for example, for data clustering. We can automatically cluster our data into some contexts, and some machine learning algorithms can identify what is the rule for data clustering. We can use dimensionality reduction algorithms. For example, you've got the information, let's say you've got the CSV file with 100 columns. Every single column describe, let's say, the country data in the context of something like technical production, industrial production, etc., etc., and you would like to create a plot, two-dimensional plot, which country is where on this chart in the context of population. So, for example, you need to compress 100 dimension into the 2 dimensions. So there are algorithms called, let's say, PCA, component principal analysis, where the new dimensions based on all the dimensions will be created. And sometimes you would like to provide the information to what are the associations rules in your data. For example, in this context, there's an extremely interesting case from Titanic tragedy. There is a data set called Titanic, where you've got the information about every passenger, what is the sex of this passenger, it's adult or child, what is the class on the ship, and the information, is this person survive or not. So the associations rules, seeking for the associations rules is something like, what was the reason why this particular person was survive or not? This is the association rule. And if you know what kind of task you can solve with machine learning, and I'm pretty sure that every single job we've got, it's possible to match with one of these jobs. So you can use different techniques for learning the software. For example, you can use a supervised learning, where you provide input data from to your model, to your machine learning task, and you provide output. So, for example, if you've got the 8 years of programming in Ruby, and you've got 10 years in experience in IT, and you are graduated in computer science, etc., and you live in Wrocław, you live in Poland, and you are under, let's say, 28 years, sorry, your salary is something like that. You provide the input and provide the output. The insight is the model you would like to create automatically. And this model will be ready to predict what is the salary for different data. For example, if you've got the, let's say, 7 years in programming in Ruby. You can use some unsupervised learning, where you provide only the input data, no output. For example, automatically, if you would like to cluster your data in the automatic way, the clustering sometimes doesn't need to be connected with the output. And the last one, the reinforcement learning, you can apply if you would like to check your decision from the machine learning model from the environment. So your machine learning model can introduce a decision. This decision is introduced to the environment, and you've got the feedback from the environment. So, for example, if you are if you would like to train a model for a game Go, okay, this step on the board, and you've got decision, you've got the feedback. Okay, your decision was good or not. And maybe this approach is not the best idea to learn vehicles how to drive. Okay, you turn right, you hit the tree. Okay, it's not the best idea. So about the real usage, how we can use a machine learning in real life. I spent a couple of years, I think almost 4, in Warsaw, when I was involved as a CTO in company which were working on the real-time content recommendation platform. And we use a machine learning to predict the probability about the clicking links. What is the probability you will click this particular link we will show you? So if you've got, let's say, 25 million of active users per month and you've got 10 millions of links, you need to create some classifications model just to earn money. Every wrong decision was about losing the money. So a couple of days ago, I was in Canada, where my friend Marco PIVETTA had very interesting talk about the event sourcing. Marco is working on his personal application for code reviews, and this application is event sourced. There are some interesting presentation of this software. It's not published yet, but I hope it will be. So in this application, there are a few steps, but one is very interesting for me from the machine learning context. When someone creates a pull request to be reviewed in the system, the developer behind need to create an estimation what will be the cost of this particular code review. So for example, and then client can accept or reject this estimation. So our input data maybe will be something like that. We've got the URL to the pull request, and we would like to have a prediction what the price of the code review for this particular pull request will be. And we would like to predict this information based on this information. So this is a perfect example, I think, for regression problem. It's about the predicting values, predicting continuous value, and the price is continuous value based on some data. So the question we would like to create for our machine learning is something like, what is the price for the pull request we need to review? So if you can use the machine learning for creating some estimation, we will save our time just to earn money more. So this is very hard to analyze URL of pull request, right? But our first step maybe looks like that. We've got the pull request, and we've got the information how many files are in the pull request and what is the overall number of the lines if this all the files published in the pull request. And this is information about the price from our history. And we've got another. If we've got a lot of information from our past code reviews, maybe this is possible, I don't know, maybe, to create a model which will be ready to predict the information what the price should be for the another values. So I wrote this really simple script. Oh, sorry. Just a second. Okay, I wrote this very simple script based on one machine learning library, very simple. It's not production ready, okay? It's just a demo. We would like to run some script, and the input data are the overall number of the files. This is this number, and what is the overall number of the lines in submitted files. So this information, 1 and 9, this is the price for this pull request based on data I provide into the machine learning model. So if we started to change some data, the results should be different. Oh, sorry. Well, yeah, the script is very simple. I've got some few data points for the history, overall number of the files and lines, and what is the price for this code review, and few lines for creating a model. Of course, as I said, this is not a production version, right? Because in production, we would like to have some better information for every code review we need to classify. So this is an example about the prediction, generating predictions based on some data. And to be honest, I didn't find many libraries for Ruby to create machine learning models. Most of them are written in Java or Ruby or Python, sorry. So if you are the Python developers or you know the Python syntax, this is an example from Scikit. Scikit package is a really, really nice library for creating and validating models. And most of the modern machine learning algorithms and concepts are implemented into this library. This example is about creating random values and creating two models like isotonic and linear regression. And on the screen, you can see that sometimes the difference between the data predicted by the model is completely different than data from the real. It's all about the accuracy, all about the measuring the performance on your algorithm. So in this example related to the code review, one more time, doing without the knowing what are you doing is a recipe for the failure. And what is more, if you don't know your data, this is another recipe for the failure. So using the machine learning approach, you need to apply one step more. UDF, it's not user-defined function, it's understand your data first. So in this example, we've got two entries, and maybe we've got another entry. So the question is, why this price is completely different? Because of maybe the better information should be not what is the overall number of the files and the overall number of the lines, but what is the size of the div submitted to be reviewed. And yeah, in this situation, yeah, this maybe is a little bit better. So in this example, it's not about the using algorithms, defining what algorithm I can use. It's all about transforming the pull request into the set of the vectors, set of the numbers, sorry. So the question to you, what kind of information I can get from pull requests or from the code to create some model from the predicting what the price should be? What is your opinion? What I can use to fit my model? Mm-hmm. Yeah, we can discuss it. So what information I can get from the code? Maybe. What else? Hmm? Yeah. What else? Number of comments. What else?
Number of change files. What is the commit size compared to the full software size?
Maybe the better answer is all I can fetch from the data. Maybe this is the number of the classes. Maybe this is the number of interfaces. Maybe this is inheritance level. Maybe this is a number of the methods or function calls. Maybe this is about the afferent and efferent coupling. If you are not familiar with afferent coupling, try to find a really, really nice article from Object-Oriented Metrics by Uncle Bob. It's about the coupling in the software. So this is a measure. I can use this information into my model. So maybe I can use the logical analysis of code metrics or LCOM. What's the LCOM is? Like cohesion of methods. This is a perfect metric for identifying if the single responsibility principle is broken or not. This is a heuristic, of course, but like cohesion of methods is very, very important. So, for example, if your LCOM metric per file is huge, you will have a lot of work. If the metric is 1, okay, there's a huge chance you will have, you will not spend so much time. So you need to identify every single piece of information you can get from the pull request and put into this model. And maybe the model or the algorithms will be helpful and some information will be automatically rejected depending on the algorithm you use. So, for example, you can use also another algorithms, like for example, clustering and the k-means algorithm. For example, we would like to cluster our data, our commits, into some context. For example, I would like to identify which commits or which pull requests were created by the junior or the senior developers, maybe. And when we're speaking about the k-means algorithms, there's a perfect explanation for this algorithm. It's called IRIS dataset. Who is familiar with IRIS dataset? Oh, cool. IRIS dataset is the dataset created many years ago by Ronald Fisher. This dataset about the flowers. Every single flower, and we've got 3 different versions of iris, and we've got the information about the petal and setal width, 4 numbers for every single flower, and based on this data, you can create some machine learning models and some more. You can create some analysis on this data. Before you start every job related to machine learning, you need to understand your data. So for example, you can use some exploratory analysis. You can create some scatter plots from your data, because if you see the numbers, you will see nothing probably. If you see the picture, you can see something interesting. For example, that some parts of the data are perfectly separated, and you can use this information in your model. So, for example, this is another case from the scikit library. You can use a k-means algorithm to create automatically clusters in your code. So, for example, I think we can use the k-means or some other clustering algorithm to expand our data set. So something like that. We can use the clustering methods for data introduction. This is a short demo how k-means algorithm can use. So you've got the different data, completely different, 2-dimensional different data, and you would like automatically cluster this information. Oh, sorry. Bang, data cluster it. And of course, you would like to have a knowledge about how this algorithm works, and etc. There's a perfect explanation on Coursera or Wikipedia, and I think we have no time for that. But you can use different algorithms just to cluster data. So, for example, some clothing companies are using this simple algorithm to predict what kind of sizes of the clothes we need to introduce on every single market we are available. For example, in Poland, SML, small, medium, large is absolutely okay, or we need to introduce extra, extra, extra large. So the overall number of the clusters will be the overall version of the clothes we would like to introduce. Maybe you would like to use some more sophisticated algorithms like support vector machines or fast artificial neural network to create some even more sophisticated insight from your data. For example, you would like to classify your data automated way to find a junior developers. So the question is not how this algorithm works, to be honest, because this algorithm is extremely nice and very well implemented in many libraries. In the real world, you will not implement it in your own. You need to focus, you need to be focused on preparing the data. So speaking about the technology, most of you are the Ruby developers. And I said I didn't find many libraries for this language, to be honest. But you can use also some other languages. You can use a Python. Many companies are using the Python for some machine learning algorithms and some machine learning processes. The scikit library I mentioned a few times. If you are a C++ developer, there's a ML pack the library which implement a lot of other good machine learning algorithms. And there are more, there are more, there are more. The project I mentioned at the beginning about the classification was implemented in R language. R language is a language created by statistician, and this language is extremely hard to learn. The syntax is awful, to be honest, but the possibilities of this language and the possibilities of the library offered in this language are wow, just wow. So for example, there is a library called Caret. Caret is a unified interface to touching, I think, over 120 different machine learning libraries. So you've got the single interface to use different libraries. So all you need to know is what kind of algorithm I can use and what are the best parameters for tuning for algorithm I can use. So our language is very, very famous and very popular in some machine learning and then some data scientist applications. So you can even use some frameworks like Shiny for creating an data-powered analytics web applications. So you can use the R language on the backend and you can use the R language on the front end. It's compiled, interpreted to JavaScript. And on this page, on shiny.rstudio.com, there's a very nice gallery of this application. So after the conference, I suggest to visit this page because this is very, very important. You can also even hide your R processes behind the Apache web server, or you can demonize your application written in R as a daemon on the Linux server. And this is approach we introduced. We wrote an application in R, it was demonized and run on the server as a daemon, as a system Linux process. So, to be honest, it's not about using the tools, writing a machine learning application. It's about the ideas, because tools will change. Tools will change. The ideas are immortal. This is a simple explanation. In 99.99% of the application, you will not write the algorithm from the scratch. You will use some prepared and tested algorithm. The question is which one, and how can prepare my machine learning data for this particular algorithms. In Scikit library, there is a very interesting guide for the people who don't know which algorithm to use. So if you don't know what kind of algorithm you can use based on your data, based on the amount of data you have, you can use this graph to select the algorithm. Of course, this is a simplified version because there are a lot of more different algorithms. But even if you choose one single algorithm, you need to remember that the machine learning in real life is not about the single run of algorithm. It's a workflow, it's a process. Because let's say, okay, if you've got the information, what kind of problem you would like to solve? You identified your problem. This is the first step. Try to identify your problem. This is a classification, regression, association rules, or maybe some other machine learning task. Then you need to gather your data. And you need to understand your data. This is a place where you can apply all the methods you know for data analytics, like exploratory analyzing using the scatter plots or things like that. Then you need to prepare your data for the machine learning. So, for example, if you would like to maybe not prepare, you are working on the model for predicting the price for the cars, and you've got the information. What is the brand of the producer? What is the age of this car? What is the, I don't know, maybe the overall amount of money in repairing in history of this car? Maybe you would like to create some better information, because if one car, someone spent, let's say, 100 zloty on repairing, and some others spent 1,000 zloty of repairing, and then there's another person who spent 10,000 zloty of repairing a single car. You can't compare this information. You can't compare this information without having information about the total price, initial price of the car. So sometimes you need to prepare. Maybe you would like to create some normalized data. I don't know. It's based on your domain. If you've got your data prepared for machine learning, then you can ready to select a job. What kind of algorithm I can use? What kind of parameters I can use to tune my algorithm? Maybe during the tuning I can create different models. Let's say it's very common to have 20, 40 different models created in machine learning process, and you need to select, let's say, one or two of them to be final models. You need to be sure that this model is absolutely okay for my data, for my test data and for my production data. So as you see, this is a workflow, not single job, not single machine learning library installation and putting this data. Our second approach I introduced at the beginning, the naive machine learning approach, was about this step. We've got the data, okay, we've got the algorithm, and that's all. No, it's not. From my perspective, for a few years of using the machine learning, the preparing the data is the most important step in this project. So if your data are wrong, if your data are not contains the most important information, the rest will be probably very, very wrong. So please do your best in this step about the preparing your data. So in this information, we've got the information about the developers, about maybe the language, about the comments and everything you said a couple minutes ago. But if we don't know what was the currency from the code review, so how we can predict the information? So that's more from my side. If you've got questions, so I think this is a really nice place. So
okay, who want to ask a question? Thanks. Can you elaborate maybe on your project with your friend? So how you classified those links? Because it was kind of interesting.
Okay.
So what were the major factors that were important during the classification? Thanks.
I don't think I can introduce all this information, but I can introduce a little bit more the whole process. So we decided to choose, I think it was 20,000 of links, and all these links were checked by a domain expert, someone who has ability to check this information if we would like to have this link or not. Then we gave this information to another domain expert, and to the final model, to the final algorithm, we use only this data where the domain experts were agreed, and both in positive and negative links. We had some predictions from our experience what the features we introduce into the CSV files should be important for the model, and we were wrong. We were completely wrong. For example, we were pretty sure that the overall number of outgoing links into the footer of the page should be important. Not the model decide that something different should be more important. For example, the information about what is the size of the comment of the page and how the content of this page and how this content looks like. It looks like the text or just crappy text. So this kind of information. I think in next 2 months, some part of this project will be published on GitHub, but not now, unfortunately. But this was very, very important, and we made a lot of mistakes during this project. For example, our first approach in the final final approach was something like that. Let's classify it into two groups, okay or not okay, and how you can classify the link which is exactly below the groups. So we create a small margin inside, okay? For these links, there is no feedback from the model. Decide yourself. And the information from you was introduced to another version of the model. Okay?
Okay, so you already answered my question, because I was going to ask how you did actually measure the performance of your model. And as you mentioned, you just had some test data checked from a domain expert.
Exactly. If you, for some algorithm, you can use some test before you introduce to the production. For example, if you've got 1 million items classified somehow, and so you can split your data set into, let's say, 2 or 3 groups. For example, you can create a model based on, let's say, 60% of data. So from overall amount of data, you can use some part of them, most of them, to create a machine learning model. And you can use the rest of the data, which is not here, to check what is the accuracy of the model. You know what the answer should be, so you can test your model. So you can even split this information, this group, into 2 groups for some cross-validation techniques to be even more sure that your model is perfect. So in our second approach, the naive machine learning, our data set, the input data set, was very, very small. And we identified the problem called overfitting, because our model was very, very fitted our learning data set. And the accuracy of on the production data was extremely low. But on testing set, yeah, it was cool.
Okay, thanks.
So did I understand correctly that you have to provide as much data as possible, right, for your algorithm?
To model?
And is it possible to provide too much data, like so that the algorithm gets confused?
Yeah, it's possible. In our data set, in our initial data set, we've got almost 100 features, but we decide to remove some of them. For example, usually you would like to remove a columns, a features which are perfectly correlated. If you've got two values which are correlated in the whole data set, you will probably would like to remove one of them, because some algorithms are not so happy when you've got the correlations on different features. The question is, which features should be removed? So this is a step with the data preparation. You can check your data set for some correlation, and if the correlation exists, okay, check this, removing the operation. And maybe this is very hard if your data set is huge and you've got, let's say, 10,000 features, 10,000 columns for every single item. This is a case from my colleagues from Szczecin. They are trying to identify the fraud transactions, and every single transaction is described by 10,000 features. So this is hard to identify which of them should be removed.
I wanted to ask, what's your motivation behind using Ruby to write that script, or actually to do that job you had to do, when there are actually a couple of better languages?
In the context of machine learning?
Exactly.
I'm not using the Ruby as the main language for the machine learning. For the proof of concept, or for the projects we would like to check our ideas, we are using the mostly R language, because we can express our ideas in very, very small amount of code. For example, after 3 months of development, the final code behind the model was just 200 lines. The rest of the time, it was learning, checking the data, generating the models. In the real world, the Java and the Python languages are probably the most popular, platform for generating the models. And in the project I mentioned, the content recommendation platform, we used Apache Spark, Apache Cassandra, Apache Storm, and Hadoop for some data analytics and creating the models. In this project, we use Java because we have a lot of data, a lot. So this is a reason why we use Java. Okay, so if you've got some other questions, so please join me here. I will be somewhere in the after party. So thank you one more time for joining this session.
Thank you.